All right, this is our last set of notes before our next test. We are going to be writing exponential functions as mathematical models. So remember, an exponential function, y equals a times b to the x power, where a and b are constants, and x and y are the independent and dependent variables. So x is your independent, y is your dependent, and we are going to figure out what a and b are. So when we are given these types of word problems, these are all going to be word problems, so you have to read. The first thing we're going to do is define our variables. So let's start with the punctured tire problem. On your way home from school, you run over a nail. The pressure in the tire decreases exponentially with time. That's how we know we're going to represent this with an exponential function. So it's decreasing since you ran over the nail. After 4 minutes, the tire pressure has already dropped from its initial value of 36 psi to 18 psi. Write the equation for this function. So the first thing we are going to do is define our variables. So remember, x and y, that's our dependent and independent variables, and we're going to be solving for a and b. So y in this case is going to be the tire pressure, and those units are in psi, pounds per square inch. And then our independent variable x, that is going to be time since we ran over the nail. And in the problem, we were told that the difference was 4 minutes. So we're going to be measuring time in minutes. Okay. So now, to write the particular equation for this function, remember, y is equal to a times b to the x power. Well, we were given two different points of reference. So after 4 minutes, so when time was 4, our pressure was it was 18. Sorry, it dropped from 36 to 18. So when time was 4, it was 18 psi. If its initial value was 36, that means when time was 0, it was at 36 psi. So this is going to be our reference, because we need to determine what a and b are. At time equals 0, our y is 36. So 36 is equal to a times b to the 0 power. Well, anything to the 0 power is 1, so 36 is going to be equal to a times 1, which means that a is 36. So all we have to do now is find b by using the second set of data points we were given. So again, y is our psi, so 18 is going to be equal to 36, that we just found a was, times b to the x power. X is our time, and time is 4 minutes. So we now have the second equation that we're going to use to solve for b. So let's get b by itself, divide by 36, that's 1/2. So 1/2 is equal to b to the 4th power. So how do I undo that 4th power? I take the 4th root of both sides. And you can do that in your calculator by raising 1/2 to the 1/4 power. So 1 divided by 2 to the 1 divided by 4 power, and we get that b is, and we're just going to round to 2 decimal places, about 0.84. So the equation is going to be that y, our tire pressure, is equal to 36 times 0.84 to the x power, where x is time. Now, one way that you can make sure that your numbers make sense is because we're decreasing. So think about when we had exponential decay, that number needs to be less than 1, and it is here. So we are going to be seeing a decrease in the tire pressure. Okay, so now that we have our equation, we can look at step B, which is if it takes you 12 minutes to drive home from school, find the PSI after 12 minutes. And will we make it home before the tire pressure drops below 5? So 12 minutes, that means that x is equal to 12. So we are going to be solving for the tire pressure by plugging 12 into x for our equation. So 36 times 0.84 to the 12th power. Type that into your calculator, and we're going to get that y is about 4.44 psi. So that was 12 minutes. And so did we make it home before the tire pressure dropped below 5 psi? And that answer is going to be no. It would be 4.44 by the time before you got home. Okay, one more problem. We are now going to look at the bacteria problem. So we suppose that the number of bacteria per square millimeter in a culture in your biology lab is increasing exponentially with time. On Tuesday, there are 2,000 bacteria per square millimeter, and on Thursday, the number has increased to 4,500. So again, we're going to be writing an exponential equation, so y equals ab to the x power, where x is our independent variable and y is our dependent variable. So let's define those. Our dependent variable y is going to be the bacteria per square millimeter. So that's, and I can't spell bacteria, close enough. Bacteria per square millimeter is our y, and x is our time. And if we are going from Tuesday to Thursday, we are going to be measuring this in days. All right, so let's find the particular equation. So we're given two sets of data. On Tuesday, when the day was Tuesday, our bacteria was 2,000 per square millimeter. And on Thursday, it was 4,500 bacteria per square millimeter. So we can use Tuesday as our starting point, as in when time is equal to 0. So when we have 2,000 bacteria, A times B to the 0. Time is 0. That's our initial day. So remember, B to the 0 power is 1. So that means that A is equal to 2,000. Now we can use our second set of data points to find what B is. So on Thursday, 4,500 bacteria per square millimeter is equal to A, which is 2,000, times B to the number of days that have passed. It has been 2 days since Tuesday on Thursday. So 4,500 is equal to 2,000 times B squared. So we divide by 2,000, and we're going to get 2.25 is equal to B squared. And so to solve for B, you take the square root of both sides, and B is about 1.5. So the equation for the bacteria problem is 2,000 times 1.5 to the x power, where y is the number of bacteria per square millimeter, and x is time measured in days. Now, again, we are increasing here, so think back to exponential growth. That number should be greater than 1, and it is. All right, so how do we predict the number of bacteria per square millimeter that will be in the culture on next Tuesday? Well, next Tuesday, that time will have been 7 days. So we are going to plug in 7 in place of x in our equation. And again, plugging that into your calculator, we're going to get about 34,172 bacteria per square millimeter. Predict the time when the culture reaches 10,000 bacteria per square millimeter. So on part C, that is our y value we're given, and we are going to be solving for x. So 10,000 equals 2,000 times 1.5 to the x power. So first we'll divide by 2,000. That'll get us 5 is equal to 1.5 to the x power. Now, this is an exponential equation. How do we solve an exponential equation? We rewrite it as a log. So that'll be log base 1.5 of 5 is equal to x. So log base 1.5, math alpha math, 1.5 of 5. That is going to be about 3.9, which is 4 days. So 4 days from the initial day after Tuesday. All right, and then drawing a graph of the function. Again, this is going to be exponential growth. So when time was 0, we had about 2,000, and you should be seeing growth from there. Okay, and that is it for that set of notes.